All right, let's jump right in. We're talking about configuration in run, or CIR. We're going to dive deep into how you can modify your SIMATIC S7-400 system while it's up and running. No shutdowns, no downtime. Let's get to it. Hello and welcome to Technical University. Technical University gives you practical, hands-on learning in industrial automation, PLC programming, networking, and troubleshooting, all online at your own pace. You get expert-led lessons, guided labs, and personal support from EPAL Copilot, so you're never learning alone. Earn certificates that prove your skills and help you grow your career, anywhere. Okay, so here's our game plan. First, we'll cover the absolute basics of CIR, what it is and what you need. Then we'll get into the nitty-gritty, activating it, adding new hardware, live, and even tweaking parameters on the fly. And to wrap it all up, we'll do a quick comparison with its bigger brother, HCIR. Let's go. All right, Section 1, CIR, the basics. Let's lay the groundwork here. We need to understand the fundamentals, what it can actually do, and what you're going to need to get started. So who gets to use CIR? Well, it's available for specific standard S7-400 CPUs and even the fault-tolerant H series. But, and this is a big but for the H CPUs, you have to be running it in what's called a 1-out-of-1 design. All that means is you're using a single H CPU in a standard, non-redundant station. It's not for a full redundant pair that's just temporarily running on one processor. Okay, so picture this. This is the typical playground for CIR. You've got your central S7-400 controller, that's the brain, the Profibus DP master. CIR is basically the magic that lets you perform remote surgery on the nervous system. You know, your distributed I/O like ET200M stations and other field devices, all without ever putting the brain to sleep. This slide right here, this really shows the multi-million-dollar problem that CIR solves. On the left, that's the old way. Any little hardware change meant a full AS stop, a complete nightmare in terms of lost production, right? CIR just completely changes the game. It cuts that stop step right out, letting you download hardware changes directly to a live running system. It's an absolute game changer. So what can you actually do with this power? Well, you can add or pull I/O modules from an ET200M rack. You can add entirely new I/O stations to your network, and this is incredibly useful. You can change the parameters of existing modules on the fly. Of course, a feature this powerful has some ground rules. You need the right versions of your software and firmware listed here, but let me highlight two things that are absolutely critical. First, your user program must contain these specific organization blocks, or OBs. Think of them like your system's built-in event handlers. They catch any hiccups during the live reconfiguration and prevent the CPU from faulting. Second, you have to disable constant bus cycle time. You need to give the system that little bit of timing flexibility to integrate the new hardware smoothly. Okay, let's get practical. Before you can do any of the cool live stuff, there's a crucial one-time setup you have to do. And this initial prep work has to be done with the CPU in stop mode. This lays the foundation for everything that comes next. The magic of CIR really comes down to these two things: the CIR object and the CIR module. Think of them like making reservations. The CIR object is like reserving slots on your entire Profibus network for future devices. The CIR module is more specific. It's reserving I/O address space inside an existing ET200M station for new cards you'll add later. Activating CIR in your hardware config is pretty simple. You just highlight the Profibus line, select Activate CIR capability, and the system inserts those placeholders for you. Then it's your job to configure them, to define your resource needs, and then, critically, do one initial download to the CPU while it's in stop. And here's what that looks like in practice. The moment you activate CIR, Step 7 just drops in the placeholders. You can see the CIR object appears on the Profibus line, and the CIR module gets slotted into the E200M rack. The system is literally pre-allocating the resources you'll need for your future expansion. Now, if you dive into the CIR object's properties, you find the most important setting, the guaranteed number of slaves. This is where you tell the system how many devices you plan to add later. Be aware, this number directly impacts the CIR synchronization time. That's the tiny blackout period during a live download. You have to make sure your process can tolerate that brief pause. It's the same idea at the station level. When you open the properties of the CIR module, you're defining the reserved I/O address space. How many input and output bytes to set aside for the new cards you'll be adding to this specific station. I cannot stress this enough. After setting up all your reservations, this first download has to be done in stop mode. This is non-negotiable. It's the step that locks in those resource reservations and prepares the live system for all the modifications you'll make later. All right, with the prep work done, we get to the payoff. Let's walk through Section 3, Adding New Hardware. This is where we modify the live system, all while the CPU stays in run mode. Adding a new device is incredibly intuitive. You just open the hardware catalog, find your new ET200M station, and drag it right onto that CR object placeholder. You're essentially cashing in your reservation and turning it into a real configured device. And the system is smart about it. Notice that after adding the new slave, the guaranteed count in the SIN object's properties automatically drop from 10 to 9. It's a live counter, always showing you exactly how much expansion capacity you have left. And this is the power of CIR right here. With the new slave configured, you just start a download. The system detects the CIR setup and lets you download the changes in run mode. You'll see the CPU's interface LED light up for a moment, but the program just keeps on running, completely uninterrupted. The process is just as easy for adding a single I/O module. You just find the card you need in the catalog, in this case an analog input, and drag it onto the CIR module placeholder in that station's rack. And just like before, the final step is the download. After adding the new I/O card, you download the modified configuration. The system prompts for a run mode download, and once you confirm, that new I/O is integrated into the live process, just seamlessly. Now, CIR isn't just about adding hardware. It also gives you the powerful ability to change the parameters of existing operational modules without stopping the CPU. Let's look at that in Section 4. Here's a perfect real-world scenario. Imagine you need to replace a valve that uses a voltage signal with a new one that needs a 4 to 20 milliamp current loop. With CIR, no problem. You just open the module's properties and change the parameter for that specific channel, all while the system is live. After you make that parameter change, you just download the configuration in run mode. Internally, the CPU calls organization block 83 to handle the update, and it applies your new settings to the live module without a single hiccup. Finally, let's distinguish between standard CIR and its more powerful sibling, HCIR. Hola y bienvenido a Technical University. En Technical University obtienes aprendizaje práctico y aplicado en automatización industrial, programación de PLC, redes y resolución de problemas. Todo en línea y a tu propio ritmo. Tendrás clases guiadas por expertos, laboratorios paso a paso y asistencia personalizada de ePal Copilot, para que nunca estudies solo. Recibes certificados que validan tus habilidades y te ayudan a impulsar tu carrera, en cualquier lugar del mundo. Which is built for fully redundant S7-400H systems. It's an important distinction. So standard CIR, as we've seen, is focused on distributed I/O changes, adding and removing modules and slaves on Profibus. HCIR, for redundant H systems, can do all of that, plus much more powerful operations. We're talking changing the CPU's memory configuration, modifying its parameters, and even adding or removing S7-400 modules from the central controller racks themselves, all while maintaining bumpless, redundant operation. Ultimately, the ability to make live hardware changes is a paradigm shift for maintenance and upgrades. It enables phased expansions, continuous optimization, and the elimination of that costly downtime. So the real question it leaves you with is this. With the factory running, what will you improve first? Thank you. If you enjoyed this video, subscribe so you never miss new lessons, tips, and step-by-step tutorials. Subscribing helps you keep learning, and it helps us grow this learning community. Remember, Technical University is always accessible at technicaluniversity.com, where you can explore full courses, guided labs, and earn your certificates.